So welcome to this seminar titled Generating Interactive Visualizations with Plotly on Graham. The focus of this presentation is really to give a view of an environment set up for generating interactive figures quickly. In particular, using it to generate figures of tabular data that we typically generate in the command line. So the example that I'll be using is generating job records, querying the jobs from an account, which we typically examine in the terminal, just as columns and searching it there. But often what I like to do is just plot summaries of the properties of that tabular data. And what I've wanted is basically to get rid of the overhead, trying to find the easiest way of just saying, okay, I've got this tabular data, I've queried this stuff, I've got this output in the terminal. What is the fewest steps to now generate these interactive summary visualizations? So the way that we've been doing this is using Plotly inside of Python and running that on the Graham system. So we'll be going over some of the figure generating power inside of Plotly. This is mostly about the environment of easily going from text columns in the terminal to interactive visualizations generated with Python and Plotly. So to get started, I'll give an overview of the resources that we're going to be using in this talk. So this is really about how not so much the diversity of plotting with Plotly, which is a huge library, but this is about creating the environment efficiently so that it's easy to generate these figures. So the resources that we're going to be exploring are for the interactive figure generation on Graham. In particular, we're going to be using Visual Studio Code to do the SSH connection over to Graham. And this gives us a nice editing suite and terminal that we can use to generate our scripts in Python. Then what we're going to do is we're going to use an SSHFS file mount. What this will do is it will then allow us to access files that we generate on Graham with the software that we have on our local computer. So the thing that we want to do is generate figures offline as HTML files, and then just use a browser to view them. So if we just create an SSHFS mount, we can use our local browser to interact with figures that we generate over on the cluster. Another way of doing that is actually just creating a graphical interface connection to the Graham VDI node using Tiger VNC. And then that way, we're using the Graham VDI node visualization, and then we can just go and interact with the HTML files on the directory on Graham. So we'll be generating the data using Slurm, which there's all kinds of ways of generating tabular data for different aspects of the system. In particular, we'll be using salloc to generate job records. And we'll be doing that from inside the terminal in Visual Studio Code. And then the other thing is, we want this to be the sort of thing that we can use just while we're doing trivial management tasks. Oftentimes, whenever I just want to check the job records for an account, I just go to the login node and I start building summary tables from S accounts and then just looking at it in the terminal. But what I want to do now is actually generate summary figures of that. So oftentimes I'll be doing this in the login node. But if we're doing this in the login node as just these quick little tasks, we want to make sure that we can also monitor the resources that we're using there, because we need to keep the tasks that we do there trivial in size and duration. So we'll monitor the top of the resources that we're using while we're generating these figures. The tools that we're using to generate the visualization. So I mentioned we're using the S account. Well, actually, above the salloc was actually to go to a login node once the resources are too large in the summaries we're building. So we're going to use sacct now to actually generate the job records that we'll be plotting. The pandas package in Python is what we're using to read in the table data from a text file into a Python data frame. And then the data frames work very efficiently with the Plotly graphics library in Python. And we use this to not only generate figures, but generate them as HTML files that are offline, and then we can just use a browser to view them. So then finally, we'll actually be viewing and interacting with these figures. First of all, using just the browser on my local machine that we can use because we do this mount, and then using browser in the Gram BDI node that we access using Tiger VNC. So really, that's the environment that we really want to present. Once you have this environment down for generating figures and then exploring them, then it gets easy to start navigating and really exploring the Plotly library and everything that it can do. So here's a high-level view of basically the environment that we want to set up for what we're doing today. So, we're working at home on our laptop, and then we can run programs on the laptop, the functions here. Now, what we want to do is we want to access the login node, and to do that we use SSH, and that brings our terminal over to the login node, and then we can run functions. Now, typically for production work, we then start submitting jobs with SBatch. But the main thing is that to do this SSH connection this time, we're going to use the Visual Studio Code. So this Visual Studio Code is just a nice code editor and terminal. And that's where we're going to be running the tools to build these figures. Now, on the login node, we also really want to make sure that we're monitoring the resources that we're using. So we'll be monitoring top. If the resources become non-trivial, so if we start looking at big data sets, all that we want to do is maintain these same resources, but then move down onto a compute node using salloc, which will basically give us the compute resources that we need that are isolated and accounted for. So what we're doing is we're basically showing the entire trajectory of going onto the Gram login node, building a Python environment that has all these plotting tools, generating a data file, exploring it in the login node while monitoring that we aren't using too many resources. And then if we do end up using too many resources, there's basically no consequence to then going down to a compute node to do a large scale analysis there. Okay, so the main thing that we're going to be using to do this work is the Visual Studio Code. And this allows us to do code editing. It's this nice little editor interface. And we'll be basically, this is the figure that we're going to, the figure code that we're going to talk about today, which generates scatter plots of job record data. So we're going to be editing our code in here, but we also have this terminal where we can interact with the scheduler, build data frames, as well as then create an interactive job that would go to the compute node and then just keep working there. So the other thing that we'll do is, because we want to be generating these interactive figures, we're going to want to use just software that we have on our local computer to visualize those HTML files. So we're going to do an example where we perform an SSHFS mount to the Gram system, and then looking at the specific folder that I'll be doing the demo in. And then what happens is we'll be generating these HTML files. And then, I'm basically looking at the file mount on my local computer. And if I click on that, then we can visualize these summaries in my default browser on my local machine. So that's really the goal. This is what we want to achieve today, is just sort of set up the environment where this is a very streamlined process, where it basically takes one more command. After you generate a table in your terminal, it really just takes redirecting that to a text file, and then one command to then generate these figures that you can explore uh, um, with a graphical interface, rather than trying to interpret the table data inside of the terminal. So the other way to view it, I mean, these files might have, these analyses might end up getting very big, and we want to actually use the Gram VDI node. So we'll also do an example, if we have time, of using Tiger VNC to set up a connection to the Gram VDI node. And then once we're in the Gram VDI node, we end up with this graphical desktop, and then we have access to the folders on the Gram system, and then I can just double click on that, and then it will open it inside the browser that's actually on the VDI node at Gram. And what are we going to do next? Right. So we're going to, right. So the one thing that we always want to be doing whenever we're just exploring data is, if we're doing it on the login node, we want to make sure that we bring up another terminal and then monitor it, monitor the Python resources that are being consumed while we do that, to make sure that we aren't tripping up at the usage. And then if we are doing something larger, this exact same process, we can just do an interactive job in the terminal, and then continue monitoring on that compute node what we're doing. Okay, so here's an example of the data that we're going to be generating and working with today. So this example is so here in the Gram login node, we're going to be doing calls to saccount, which will return this tabular data that we have listed here. Where we give it the columns that we want, like the job ID. Then we have things like start time, and then job properties. Those end up being all of the columns. So job ID, that's the submit time, start time, et cetera, et cetera, et cetera. And then we're just going to get used to doing some formatting changes on these. So in particular, this exact same command, if we just add the P, which I forget why, it might even be pretty or print, will basically just bar delimit the file. So this is now the exact same data, except it's delimited with the bar and easier to parse. And then finally, we'll just add the redirect to a text file. And then what we can do is we can just take a look at what's inside that text file. Here, I'm just doing the head of the first 12 lines. And then we see that that's the exact same data. Now, what we're going to be doing is using pandas to just read this limited text file into a data frame in Python. And then we see that that is basically exactly compatible with very easy plotly figure generation. And what's next? Right. So the first thing that we want to do is we're going to go onto the Gram system, and then we're going to create a Python virtual environment. And then the packages that we're going to need to do this work are pandas and plotly. So pandas will be generating the data frames, and then plotly will be generating the figures. So we do the module load for that because we have Python over there. Then we create the virtual environment, and this is going to favor the local Python wheels. We're going to source that environment. So now whenever we install packages, this will be our specific environment for running these specific analyses. We're going to install pandas, and then we're going to install Plotly. And that's everything that we need to do the work that I'll be describing here. Okay, so the specific example of the script that we're going to run, I think this is pretty close to what we'll actually be running today. So we start off by loading the packages that we need. Yeah, that's about all of them. Okay, and then creating the data frame is basically this one-step process where we use the pandas read CSV. This is the file that we created with the salloc. It's delimited with the bars we described, a couple other things. So it actually grabs the headers as the column names for our data frame, things like that. Then what we can do is we do some calculations where we engineer some new variables that we want. We actually get them to be date times. So a lot of what we'll be plotting today is on a timeline and plotting durations. And then I think, so yeah, here's another variable that we create, but I think we actually create it different in the final version. And then, we can print the data frame, which will pretty much look like what we saw in the terminal. And then here is the plot that we really want to generate today. So if we can generate this plot and then save it as an HTML, we're flying. This is what we want to accomplish today. So what happens is we define a figure, and then we make it equal to this plot, the express scatter. The scatter plot inputs a data frame, which is pretty much exactly in the form that we created just by reading in the text data that we generated from the sacct call. Now we set the x, so this is going to be a scatter plot. We set the x to the submit time, so there'll be a point along the x-axis for when jobs were submitted, and then we set the y-axis to the wait duration of the job. So what this is going to give us is a scatter plot of a 1 point per job in our query, where the x-axis will indicate when we submitted that job, and the y-axis will indicate how long that job waited in the queue. Then we can do other things, like we can start adding marginal diagrams, so plotting a histogram on each margin, x and y. We can add hover data, so this is what will be displayed whenever the mouse hovers over a data point, and what it will plot is actually each column's value for that data point. And then we can start doing things like coloring all the points by the partition. And then, there's other properties like the opacities and stuff like that that we can add. Now, for all of those variables, this is really where Plotly is very powerful, where the flexibility of the figures is, I want to say endless. There's a lot of power there. This is the only example that we'll work on today, but given that we can run this one, it ends up being very easy to then just explore the documentation for Plotly and start generating all these summary figures for data that you're interested in on the Graham cluster. Okay, so I think pretty much now what I'll go into is actually doing the demonstration. And the demonstration is going to go through, oh, I think I just paused the share there. Everything's fine. Okay, so the demonstration is going to go through actually logging into Graham using Visual Studio Code instead of a typical terminal. We're going to actually create the environment in a new folder that we're using. We're going to then mount that directory to our local drive so we can actually explore the files that we create using the software on our laptops. I can also SSH to the login node from another terminal so that we can independently monitor the processes that we're using while we're working on a login node on these shared systems. We'll generate the job records, and we'll read the text files as a pandas data frame, and then create the interactive plots, view them, local browser can view them on the Gram VDI node. And then if we wanted to, then we can actually just do that exact same thing by first going to a compute node using an interactive job in salloc call. Okay, so I think that's, yeah. So I'll go to the demonstration and then we'll go over documentation of what we're actually looking at. Okay, so I'm still just sharing my desktop, and what I have here is my Visual Studio Code running on my local machine. And what I want to do is I actually want to start a remote SSH connection to Gram. And I do that just by clicking the connections icon down at the bottom corner and selecting the remote SSH connection. And then what I do is I just say me at so me at gram.computecanada.ca. And then this, so the documentation for connecting to remote systems can be found in the documentation I'll show later. For some reason, that seems to be ignoring me. Okay, that's why. Sorry about that. I can never type this properly the first try. gram.computecanada.ca. This is going to be that connection. So we see here that this is now SSHing over to Gram. And in the documentation, you can find out how to set up your SSH keys so that this won't ask for your password, but will work just like logging in with a terminal. So now I see that here I am. I have an SSH connection established to Gram. So this is basically pointing at the compute nodes. And what I'm going to do is I'm going to open a folder. So this is now pointing to my home directory on Gram. And I have a demo folder. And then inside the demo folder, I have a Plotly demo folder. I'm going to hit OK. Okay. So now what's happening is I have my editor up here, shows a welcome page. I'll just close that. And then I have my terminal down here at the bottom. This terminal is currently pointing at the Gram login node. And what I'll do right off the bat is, because we'll initially start working on the login node, I'm going to go to my regular terminal over here. Make sure that I'm pointed to the same login node by default. So it should be the same one. And I'm just going to do a top U Jard. Now, this is the kind of setup, if I'm ever doing something on the login node where I'm exploring stuff, I like to just keep this up here. Anytime that I know that I'll be reading in data or starting a high-level interactive instance like running Python or something. Okay, so the next thing that we want to do is we can actually just use this terminal here to start exploring generating these data sets. So I'm doing my saccount call. I'm going to generate a table in the terminal for my account, listing all the jobs since January 1st, and then giving the job ID, the submit, the start, the number of CPUs. And then I'm just going to pipe that into head and just give me the first 8 for now. And let's see what happens. Okay. So there we have the list. I'll just move this over so we can see it nice and straight. Is basically the first jobs that we had there. Now, if I just redo that this time, I'll make this print and then run that. It's going over and it's querying the scheduler, and then it's just going to output this in a way that's more friendly to the import of pandas in Python. So now I see it generated the same thing. It's now bar delimited. And then finally, I'll do the same thing, except this time I'll just redirect it into, I'll call it test dot out, or in fact, I'll even call it junk for now because I won't use this one. So this will now, instead of just showing the top 8, it will put all of the records for that period inside of this junk text file. And then once that's done, I can replicate this by just calling for the head, the first 8 values of my junk out file. And then I see that what's in this text file is exactly what I was trying to query above. Okay, so this is data that I frequently want to explore, but I really want to visualize it instead of just having these tables that I need to become a text master to summarize otherwise. So the next thing that we're going to do inside of this terminal, which is inside Visual Studio Code, is I want to set up my Python virtual environment. So actually, I can probably increase the size of this text a bit. Okay, so increase that a bit. And then what I'm going to do now is I'm going to load the Python module. And then if we want, do things like module list to see what we have. Make sure that this is the environment that we want. Everything looks good. I'll start initiating the virtual environment, and this process is documented at the Compute Canada wiki for running Python. Do that. So this will create my virtual environment, and then what we want to do is we want to then start up this environment by running source inside the environment, then activate, and then as is documented for using Python generically in the Compute Canada systems, we see that our terminal is now in that environment. So this is the environment that we'll set up. And then from now on, we can just keep this environment every time that we think we're going to be generating figures out of tabular data from the terminal. We can just go to this directory and then start up this environment. Now, what we're going to want to include in this environment is the pandas. And we'll just grab this from the wheels. And then while this is installing, I might as well actually just go ahead and do my SSHFS mount. So while all this is going, what we want to be able to do, so that one's done installing, and then I'll just install my Plotly at the same time. And then once those are set, we're all ready for today. So what I'm doing in this window is here, I'm in my local machine in my home directory, and I'm just calling the SSHFS mount. And what I want to do is I want to mount for me at Graham the home JDeJard plotly demo folder. And then I want to mount that into an empty directory that I have called temp mount gram on my system here. So once this is done, what I can do is I can say list what's in temp mount gram. And then I see here is that junk file that I just created. Here's the environment that I just created on gram. This is actually the directory over on gram. And then I can also open my editor and see that here I actually have this is the directory over on the cluster. So this is the environment that I just created that we're going to use to generate the figures. I just created this junk output file, and then I have this test one that we're actually going to look at. And what we want to do is just be creating HTML files in here that if I double click on them, they'll just open up in my local directory. Okay, so now that we have this environment created, I have, so I'm inside my Python environment. We've installed pandas to create these data frames from the text files we've generated. And then we have Plotly in this virtual environment that we can use to turn those data frames into interactive figures. What we want to do now is actually just start creating a Python function that we're going to run. And we'll do that up here. So the first thing that we're going to do is I'm going to create a new file. And this new file is going to be in my working directory. And I'm just going to print in this beginning part where we're going to import pandas. And then we're going to import Plotly Express, which we installed into the environment. And then we're also going to import the default date time as DT, because we're going to be dealing with engineering some time variables in here. All right, so inside of this tool, I'll actually just go and I'll save this now. I'll call this job summary.py. Oh, I think I did search instead of, I'll save it. There we go. So inside of this folder, I'm going to call this job summary.py. Okay, so we see that this just created the job summary.py. That's here. And then if I go into my local browser and refresh it, I can actually see that job summary py is here. And if I double clicked it, it opens up in my default text editor over here. Okay, now we want to get into the actual work of this Python program. So the first thing that we're going to do is we're going to create a job frame. This is a pandas data frame that's created using pandas read CSV. The file it's going to read is the testjobs.out, which was generated as a redirect from the S account, and it used the bar delimiter. Now, what we can do just right away is we can start testing this by just adding a print of that. So I'll save this. Now down in my terminal, I can just start using this, and then we can always monitor the top that's happening on the side. Particularly one of the things we're going to want to watch for is if we end up using too much memory while we're running these things. So now I can call this doing Python job summary.py. And then what we see here is it just printed the read of these 25,000 job records, looking pretty much like what they were in the terminal whenever we were just listing the sequence. Okay, so what we've done so far is we've created the Python environment where we can take that tabular list data that we're interested in from the terminal and now have it as a data frame inside of Python just by calling this job summary function. Now all that we have to do is maybe engineer a few variables and then start plotting them. So I'll add things in here. So the first thing that we want to do is we're just going to actually make sure that because we're interested in understanding the time variables of this data frame, in its initial state, these are string variables for the submit time and the start time. And what I'm going to do is I'm just going to paste these conversions in. So I'm basically going to translate the submit column of the job frame using the pandas to date time, et cetera, et cetera, et cetera. So it's basically just converting those variables into date time. And then the next thing that I want to do is just actually engineer a few new variables. The first one that I'll make is an important one. So what we're interested in actually interpreting about our job history from those job records is what was the submit wait time? Like what was the difference in time between when a job was submitted and when it started? So just doing a basic subtraction of start minus submit, and then just creating a couple other ones if I wanted it in seconds or hours. And then I just create those there. Okay, so I can make sure that this is working. I'll just save this, go back here, and then just run it again. And what we'll see is now at the end of the columns, the columns, I have these new variables that control the time. And then down at the bottom here, there's a bunch of not numbers or not times. And these are because there's a bunch of jobs that don't have those times on them. All right. Now, what we've done now is we basically accomplished what we want to accomplish in this presentation, and all that's left is the important part, I guess we'll say. So all that we want to do now, I think probably the hardest part is just converting the tabular text data from the terminal into these data frames that are immediately compatible with Plotly. So what we want to see now is really that was really the hardest part. That all that we're going to do now is we are just going to generate a new figure, which is going to be a scatter plot. And then I can add a couple of things, the opacity, like this, like that. So now that we have this job frame that has all the information that we want to summarize, we just create a new figure using the plotly express scatter function, and there's a huge library of different ones. And all that we have to do is give it a pandas data frame, tell it which of the columns is X, which of the columns is Y, and then start giving it other parameters. Once we finish that, then we can save this as a HTML file using taking the fig object, writing to HTML, and then giving it a name. And this will generate it inside our directory here. So what I'm going to do is I'm just going to resave it, and then I'm going to run the exact same process in my terminal. And ideally, everything goes well. It still prints out the outputs. But now, if I list what I have in this directory, I also have this job figure.html. Now, because I've mounted my drive here in my temp mount gram, if I update the contents of this, I see that that's there as well. Now, because that folder on Gram is mounted to my local directory, I can use whatever software is here as though this is actually on my drive here. So if I double click on this, what this will do is it will open up it's actually using my last, it's using my last browser, and we basically get that figure. So here we have the start times along the x-axis, we have the submit wait in hours along the y-axis, and then each point is a job. And then by default, if I hover over that figure, that will give us the x and y coordinates. Let me see if I can just move this onto the other. All right. Okay. So there we have it. This is pretty much it. What I can do now is inside of this terminal, I can rerun my calls to generate that text file, and then just rerun my Python script to regenerate the HTML file, and then just, in 2 steps, rather than trying to summarize the text content of the job records output, I can just keep updating this figure. Now, the other thing is we can then start really playing now. If you go to the Plotly documentation, just setting up this environment will then allow you to really start playing with all the things we want to play with. So for example, with these 4 lines, we can really improve the interpretability of that plot. We'll add a marginal x histogram, y histogram, and then what we're going to do is we're going to change the hover data to actually represent each of the columns in that data frame, and then we're going to color all the points rather than all being the same color. We're going to color them based on the partition column in the data. So what I'm going to do now is, actually, I'll save this, and then I'll just rerun it. Go through. That's done. And then that would have updated in my mount, which means that if I just update my browser, this will now give us the new figure that we've generated by entering those new parameters. So now we see that the different jobs, in particular, we see that the jobs with the longest wait time actually belong to a specific kind of partition. Particularly, we see that this is the long duration partition. And just right away, we can start seeing how much the certain properties of our jobs are affecting the expected wait time of them. And we can get these summaries all at once. Now, from this point, the goal is really to explore how powerful Plotly is at generating different summaries using different plots, even including the analyses like the low-S fit curves and everything. But other things that we can do immediately is, by adding the hover data equal to all of the columns in the data frame, we see that whenever we hover over this one job, we can see all of the properties that we have access to, including the job ID if we want to go back to the system and explore that exact job. But we get all of the properties that we read in from there. So I think in terms of a demonstration, I just want to say a couple other things. We've been doing this in the login node. And what we always want to do is whenever we're doing things in the login node, make sure that we monitor the process and the resources that are being consumed by that process in top. And I see there isn't all that much. These are my processes, and I did have Python there, and we're fine. If we wanted more, this Visual Studio Code terminal could actually just start a we could actually just start an interactive job here by calling salloc, starting a job with a certain amount of memory, and then this terminal will go to a compute node. And once that's in the compute node, we can just exactly replicate what we've been doing here at a substantially larger scale. So going back to the presentation now, we just want to finish off by going over some of the documentation. So the goal of this presentation was really to describe the environment for quickly taking tabular data in the terminal and turning it into interactive figures. Not only can we then view those just using tools that we have, but those figures are also very easy to share. And I typically do this when working with researchers trying to interpret wait times, as I share these HTML files so that we can examine the distributions together. So documentation to dig deeper into this topic is, using Python itself. On Compute Canada, we have specific documentation on our wiki for the recommended procedures for creating your virtual environment and using it. The Visual Studio Code is a great tool for using Python in intuitive ways, and specifically there's documentation for doing the remote SSH and setting up your SSH keys to do your Graham access that way. Importantly, the Plotly Python's graphics library is very exciting. Once you're working in an environment where you can create these figures, then going in to explore how powerful that visualization is really great. This was sort of getting to the point where you can now play with these, but we have experts in Compute Canada like Alex Razumov, who's done presentations on this and can really help with the creating these really impressive and powerful figures. Not sure why that minimized. Then using a mount so that you can use your local software to work with remote files is very valuable. There's documentation for using the SSHFS mount in different places. And then if you don't want to mount, but you actually want to use the Graham virtual display infrastructure or the VDI node, we have documentation for that at Compute Canada at the VNC page. Of course, visualizing data is a very important part of research production, and this is something that we really try to support. This is very much worth the time and effort in establishing, and we do have dedicated experts like Alex Razumov in here and Wei-Guan Guam to do this. So don't hesitate to submit support tickets for visualization on these systems. And then things to consider moving forward is, really the scale of the resources available in the Plotly library. This is a starting point. If you replicate this environment and this procedure, you're in a position to really explore the full range that library can do. Also, the procedure that we just described will scale entirely. So if you are working with very large data sets, the process that we just did by asking Plot or Python to run that job summary figure can be submitted as a batch job in production. So that exact same procedure, although we've been using it interactively in the login node and talked about doing it in a compute node, that job can actually be submitted as a batch job because it generates the HTML files offline. So whenever the job completes, the output is that interactive figure. So this process also scales entirely to whatever workload you want to build these interactive figures for. And that's the end of the presentation.